The future isn't coming, it's already here. From AI to biotechnology, new innovations are reshaping how we live, work, and connect with the world around us. In this video, we're counting down 5 emerging technologies that are set to change the future, and maybe even the way we think about what's possible. Before we dive in, don't forget to like, subscribe, and hit the notification bell for more tech trends made simple. Let's explore what's next, starting now. 1. Quantum computing. Quantum computing represents the most significant leap in computational power since the invention of the transistor. Unlike traditional computers that process information in binary bits of 0 or 1, quantum computers use quantum bits or qubits that can exist in multiple states simultaneously through a phenomenon called superposition. This allows them to perform calculations exponentially faster than current computers. The implications are staggering. Problems that would take today's most powerful supercomputers thousands of years to solve could be completed by quantum computers in minutes or hours. This technology will revolutionize drug discovery by simulating molecular interactions with unprecedented accuracy, potentially leading to cures for diseases like Alzheimer's and cancer within decades rather than centuries. In cryptography, quantum computing will break current encryption methods while simultaneously creating unbreakable quantum encryption. Financial modeling, weather prediction, and artificial intelligence will all be transformed. Companies like IBM, Google, and emerging startups are racing to achieve quantum supremacy, and we're already seeing early quantum computers solving specific problems faster than classical computers. The challenge lies in maintaining quantum coherence. Qubits are extremely fragile and lose their quantum properties when disturbed by heat, electromagnetic fields, or even cosmic rays. However, recent breakthroughs in error correction and quantum stabilization suggest we're closer than ever to practical, large-scale quantum computers that will reshape every industry. 2. Brain-computer interfaces. Brain-computer interfaces, or BCIs, are creating direct communication pathways between the human brain and external devices. This technology reads neural signals and translates them into digital commands, allowing people to control computers, prosthetics, or other devices using only their thoughts. Companies like Neuralink, Synchron, and BlackRock Neurotech are developing implantable devices that can decode brain signals with remarkable precision. Early applications focus on helping paralyzed individuals control robotic limbs or computer cursors, but the potential extends far beyond medical applications. In the near future, BCIs could enhance human cognitive abilities, allowing us to access information instantly, perform complex calculations mentally, or even share thoughts and experiences directly with others. Students could download entire textbooks directly into their memory, and professionals could access vast databases of knowledge instantaneously. The technology also promises to treat mental health conditions like depression, anxiety, and PTSD by precisely stimulating specific brain regions. Artists and creators could translate their imagination directly into digital art or music without physical tools. However, this raises profound questions about privacy, identity, and what it means to be human when our thoughts can be read and potentially modified by technology. Current limitations include the invasive nature of implants, the risk of brain tissue damage, and the complexity of decoding neural signals. Nevertheless, recent clinical trials show patients successfully controlling devices with their thoughts, suggesting we're approaching a future where the boundary between mind and machine becomes increasingly blurred. 3. Synthetic biology and genetic engineering. Synthetic biology combines engineering principles with biological systems to design and construct new biological parts, devices, and systems. This field goes beyond traditional genetic engineering by creating entirely new biological functions that don't exist in nature. CRISPR, Cas9, and newer gene editing tools like prime editing and base editing are becoming increasingly precise, allowing scientists to make specific changes to DNA with minimal side effects. This precision is enabling personalized medicine, where treatments are tailored to individual genetic profiles. Diseases caused by single gene mutations, like sickle cell anemia and Huntington's disease, are already being successfully treated in clinical trials. Beyond medicine, synthetic biology is creating programmable living systems. Engineered bacteria can produce pharmaceuticals, biofuels, and materials more efficiently than traditional manufacturing. Scientists are developing biological computers using DNA as data storage, potentially storing all of humanity's information in a space smaller than a sugar cube. Agricultural applications include crops that can grow in harsh climates, resist pests without pesticides, and provide enhanced nutrition. Researchers are engineering plants that can capture more carbon dioxide from the atmosphere, potentially helping combat climate change. The most ambitious projects involve de-extinction efforts, bringing back species like woolly mammoths, and even extending human lifespan by editing genes associated with aging. However, these powerful capabilities raise ethical concerns about playing God with life itself, the potential for biological weapons, and ensuring equitable access to genetic enhancements. 4. Advanced Artificial Intelligence and AGI. Artificial General Intelligence represents the next evolution of AI systems, machines that can understand, learn, and apply knowledge across any domain at human or superhuman levels. Unlike current AI that excels at specific tasks, AGI would possess the flexibility and creativity of human intelligence while processing information at computer speeds. Recent advances in large language models, computer vision, and robotics are bringing us closer to AGI. AI systems are already writing code, creating art, and solving complex scientific problems. The development of more efficient neural network architectures and training methods is accelerating progress exponentially. AGI could solve humanity's greatest challenges by discovering new scientific principles, developing breakthrough technologies, and optimizing resource allocation globally. Climate change, disease, poverty, and resource scarcity could potentially be solved by AI systems that can think and innovate beyond human limitations. 5. Fusion energy. Nuclear fusion, the process that powers the sun, represents the holy grail of clean energy. Unlike nuclear fission, fusion combines light atomic nuclei to release tremendous amounts of energy without producing long-lived radioactive waste or the risk of catastrophic meltdowns. Recent breakthroughs have brought fusion power closer to reality than ever before. In December 2022, scientists at the National Ignition Facility achieved fusion ignition, producing more energy from a fusion reaction than was directly input to trigger it. This milestone proves that fusion energy is scientifically feasible. Multiple approaches are being pursued simultaneously. Tokamaks use powerful magnetic fields to contain the superhot plasma needed for fusion, while inertial confinement fusion uses lasers to compress fuel pellets. Private companies like Commonwealth Fusion Systems, TAID Technologies, and Helion Energy are developing smaller, more efficient fusion reactors that could be commercially viable within the next decade. These technologies aren't just cool, they're transforming our world in real time. Whether it's smarter machines, cleaner energy, or better healthcare, the future is being built today. If one of these stood out to you, let us know in the comments, or share a tech trend you're excited about. And if you want more future-focused content, don't forget to subscribe and tap that bell. See you in the next one.